I have a lot of questions
Okay.
because I really don't know what I'm doing.
All right, so let's start asking some questions then. We have also posted some extra videos too that we found today to help with this. Well, not with the review, but with just general ideas of the mutually exclusive, mutually inclusive, independent, and dependent as well for you to check out later on today if you'd like.
Okay.
So what's the first question, my dear?
So just like you just said, how do you tell if something's exclusive or inclusive?
All right, exclusive, if you think of it as a Venn diagram type picture, because most people are visual here. So mutually exclusive would look something like this in a Venn diagram. You would either be in one category or the other. There is no overlap. So I'm going to put no overlap over here.
Okay.
Now, inclusive has overlap. So if you were to draw the Venn diagram of an inclusive, do you see how that has this little section of overlap right here between the two circles?
Yeah. Would that be for like a problem where it asks you, where it says or?
Not necessarily. Or is with exclusive or inclusive. They use the word or for both of these. What this would be is think of a deck of cards, okay? So an example of exclusive would be, can you have a king that's a queen? No, you're either a king or you're a queen on the cards, correct?
Yeah.
So then you would have the kings and the queens as two separate columns here. However, with an inclusive, I could say I'm wanting red king. Is there any red kings in a deck of cards?
Yes.
That would be your overlap. So that 2 that would be in your red kings is overlap. So that's an inclusive example. Do you see the difference?
Yeah. So like for number 1 on the review, would that
Okay.
be
So let's read it. You randomly choose a tile from the bag. Find the probability of A or G. Are these events mutually exclusive or inclusive? So can you be an A and a G at the same time?
No, so it has to be exclusive.
Correct.
Okay.
Does that make more sense?
Yes.
Okay.
I was also confused on 5 and 6.
5 and 6. Let's take a look at that. All right. So the question was 5 or 6. Go to a new whiteboard over here. All right. So let's look at 5 here on the review. And it says, what is the sample space for tossing a coin 3 times? All right. So think about a coin. When you're flipping a coin 3 times, what's the possibility if you flip a coin?
50-50.
Okay, so you're either going to land on heads or tails. So when they're saying look at the sample space, they're going with all possibilities. So you could start with, I flip the coin and all 3 times I land on heads. I could also flip the coin and the first 2 times I land on heads, but the last time I land on tails.
So is it just having this list all the possibilities?
That's correct. Sample space is all of the possibilities. So then here you would have the heads, tails, heads, and then you could have tails, heads, tails, 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 heads. You could have all 3 tails, or you could have heads, tails, tails, or tails, heads, heads. So you're literally just listing all the possibilities.
Oh boy.
So that is sample space for number 5 here. And then you said number 6 as well, correct, sweetheart?
Not really anymore because I know what sample
Okay.
space means now.
Okay. No big deal.
Can you explain number 7?
All right, so for number 7 here on the review, 7 review, if anyone goes back to listen to this or see it, they know what we're talking about. It says you draw a card from a bag that contains 4 yellow cards, number 1 through 4. So I'm just going to do this like this. So my 4 yellow, 1, 2, 3, 4. And 4 blue cards numbered 1 through 4. So 1, 2, 3, 4. Tableau of events A and B are mutually exclusive or inclusive, then find the probability. All right, so for A here, for number 7, it says event A, you choose a yellow card. All right, so
that would be 4 out of 8, right?
You're talking about, well, here's the question. When you're looking at that, is it mutually exclusive or inclusive first?
It's exclusive?
Yes, because if you're going to choose a yellow card, then it's just the yellow card, correct? And it would be the 4 out of event A. Find the probability of A would be of that. So you got 4 out of 8, or 100% if you had all 4 of the cards. And then for event B, let me write this. I tried to get to where you could see the problems while I'm doing this, but it turns out to be really messy. So it's just easier for me to read it and write it. So what about, because we were struggling with the exclusive, inclusive with you. What if I told you choose a blue card?
And that's supposed to be like after you picked a yellow card, right?
Well, no, event B would just be if you choose. So part B says, get back to it. You choose a blue card for event B.
Wouldn't it be exclusive?
Mm-hmm. There you go.
Okay.
So here's the question I have. Since we've talked about exclusive and inclusive, how do y'all feel about independent and dependent?
That's easier for me.
Okay. I know I have a few other people in there. How do y'all feel about independent and dependent?
I feel like I'm confused about like all of them.
All of them as in what? All of them?
Like all of the events.
The words or the problems?
The problems.
Okay, well, do remember that there is a video going over all of it, so I can answer specific questions here, but I won't have time to go through the whole entire review in 30 something, less than 30 minutes. Also, don't forget your teacher should have posted, I know Jones, me, and Audrey have, and I'm pretty sure Miss Faya did too. There's a Zoom video going over the inclusive, exclusive, independent, and dependent too, as well, on top of the help session here. So let's just keep going through here on this. Let me get a new whiteboard here. Let's see here. So we've talked about exclusive and inclusive. We found the probability of this. So let's look at some of this other stuff, okay? So with the activity we did yesterday, we actually were able to kind of dig into a little bit more about the independent and dependent, right?
Yes.
Okay, so let's go through an example of that. If I can find one that's going to be a decent one. Okay. Let's say I have 10 cards, okay? And this was off your activity yesterday. There are 10 cards. 4 of them are green. I do actually have a green. So I'm going to have my 4 green cards here. I do not have an orange, so I'm just going to use yellow for now, okay? And the remaining are what we're going to call our orange. So that means 6 of them, right? 2, 3, 4, 5, 6. So I have 10 cards total, the 4 green and the 6 orange. And it says, what is the probability that Ken will select an orange card? All right, so I'm going to write that. So what is the probability that Ken will select an orange, or on my screen, I'll just put yellow here because that's the closest I can get to orange on here, card. All right, so with that being asked, is that independent or dependent?
Independent?
Yes. Now tell me why though.
It's independent because there's no second pick. Or if they replace the card for the second one, it would still be independent.
Very good. Independent means it does not depend on the first draw or first pick or anything like that. So this is independent. So we do have independent here. Now we have to actually answer the question here. So what is the probability of selecting that orange card?
6 out of 10.
6 out of 10. Remember, always simplify when you can. So 6 out of 10 would go to what?
3 out of 5.
3 out of 5. Or you could say, what would that be as a decimal? Does anyone know?
60%.
Oh, as a decimal though, what would that be as a decimal?
Oh, 0.6.
Very good. And as a percentage, it would be the 60%. Okay. Are we okay with that one?
Yes.
All right. So that's independent. Let's look at a different version or another version of independent dependent. All right. Are we good on this one before I go to a new screen?
Yes.
And this was 14 on that activity we did the other day. Okay. All right. So let's go to a new screen. We're just going to go up one. So let's look at 13 on that activity to help us out here. So Rojo's buying his wife flowers for their anniversary. The florist has 5 red roses, 4 yellow roses, 3 pink roses. Okay. So this is what the florist has. The question is, what is the probability don't know why I wrote that. That when he selects, he will select one yellow rose after then 2 roses. So not after, but then 2 roses. I'm sorry, guys. Not fully reading everything properly. Don't do that on your quiz tomorrow. Make sure you read properly. 2 red roses. All right. So we're choosing 1 yellow, then 2 red. So is this going to be independent or dependent?
Definitely dependent.
Why?
Because the first and second selection, well, the first selection changes the probability for the second For the second and third one.
All right, yeah, you're on the right track there. So when you're doing that, once I've chose that first rows, because I'm not replacing it, I'm keeping it for the arrangement, then it is going to affect the others. So you're all right, since there is with without replacement here, so it's going to be dependent here. So what's the probability of the one yellow rose? Let's just do it one piece at a time here. So what's the probability?
1 out of 13. 4 out of 13.
But is there 13?
I mean 12.
There you go. So the probability of our yellow is going to be 4 out of 12. Now, when you have independent and dependent, that means you are going to be multiplying. That's that and, okay? And means multiply. Then we're going to have the probability of picking 2 red. So what's the probability of picking the first red?
5 out of 11.
Very good. So that's what I was going to say. That's the key to that. Because I'm keeping the rows once I pick it, my bottom number should be going down each time. So here it would be the 5 out of 11. What about the second rows?
4 out of 10.
Yes. Because I've kept one red, and again, my bottom number should still be going down. So here you would multiply these 3 together. And remember, you can use your calculator to do that. So when you do 4 times 5 times 4, that's when you're getting your 80. And then when you multiply your numbers on the bottom, 12 times 11 times 10, that's going to be the 1,320. Remember, always reduce. Your calculator can do that for you if you have a TI-84 or even the TI-30. This becomes 2 out of 33. Or you could say as a percentage, 6.1%. So he has a 6.1% chance at pulling a yellow, then 2 red roses for an arrangement. Do you see the difference now between independent and dependent and exclusive and inclusive?
Mm-hmm.
Did that help any, sweethearts? I know there's a couple of you in here.
So for the exclusive and the inclusive, do you add them together?
So that's the or. So that's going to be the adding. Now, remember, when you have overlap, sometimes you have to take away something as well.
Yeah, that confuses me.
Well, you can't count something twice. So the example I use in class is some of my students I teach twice a day. I have them in guided study, and I also have them in my regular class. If I'm counting how many different students I see a day, I don't want to count that student twice. So you have to take away that counting.
How do you know what to take away? And how do you know which formula to take away from?
Okay, so let's look at an example of that. All right, let's look at a deck of cards one. Those are the easiest ones to look at here. So on your activity yesterday, we had a deck of card one, which would be a perfect example of this. This is the state and county like decks of cards. I'll just go ahead and tell y'all that. So this was number 3 on my activity, going over what you're talking about. So it says here, if you select one card from a 52 card deck, what is the probability that you choose a 5 or a black card? All right, so we're talking about a deck of cards here. Okay. We're trying to find the probability of a 5 or a probability of a black card. All right. Well, is this going to be exclusive or inclusive? Let's talk about that first.
Inclusive?
It is inclusive. And how you know that is, remember, you have black 5s, correct?
Mm-hmm.
So that means there's an overlap there. So that's why we know it's going to be inclusive there. So then here, to actually find the probability of this happening, well, what's the chances of you pulling a 5 from a deck of cards?
4 out of 52.
Very good. So you have 4 out of 52. Now, what about, because it does say or here, the probability of a black card? Or means add. How many black cards are in a deck?
13.
60.
Wait.
It's definitely more than 13.
26.
26. Half of your deck of cards is black. The other half is going to be red. Now, how many, so with our black, with our 5s here, I'm going to do something here at the bottom so you can see it. I have 2 black 5s and 2 red 5s in a deck of cards, correct?
Mm-hmm.
Well, I've technically have counted these 2 right here twice. I counted them in my probability of me pulling a 5, but I also counted them in my probability of drawing a black card, correct?
Mm-hmm.
So that immediately tells me when I have that overlap, I am going to have to subtract the overlap.
So did you subtract 1, or would that be subtracting 2?
You'd be subtracting 2 out of 52.
Okay.
Because I counted 2 of them twice.
Okay.
And then here, what you would do is you would say, well, 4 plus 26 minus 2 would give me my 28 out of 52, because they all have a common denominator, so I can just straight add and subtract like I normally would, which reduces to be 7 over 13, or roughly 53.8%. So that's how you handle the overlap. And if you're visual on your paper tomorrow when you're taking your quiz, draw out, kind of like what I did right here. I drew out my 4 5s, and I even color coordinated because I know a lot of y'all are visual. I know I was too. And that helps me see how many I'm over counting. Anytime you over count, you have to subtract that out. So I know for my students, when we're in the class, especially when I'm explaining this in the classroom or when we're doing stuff, a lot of times on my papers, they would have a bunch of little drawings to help guide them. And that's perfectly okay. Do that if it helps you. Does that make a little bit more sense?
Definitely, yeah.
Okay, good. I know the overlap is always the sketchy part of that because it's hard to see it. That's the reason I draw it. Okay. So I'm trying to think what else we got going on here. We've talked about independent, dependent. We've talked about exclusive and inclusive. What to do with the overlaps. Okay. Let's see what else. What else we got here? And remember, for the deck of cards and stuff like that, on your teacher's e-class page, there's a form or a picture of something that has all the deck of cards on it. So if you don't know for sure how many queens or kings or spades or whatever you may have, you can definitely check that out to help guide you, okay?
Okay.
Don't sit there and play guess what it is. Like, actually look over that tonight and be like, what is in a deck of cards? I know not all of us have played with a deck of cards recently. So let's see, what else? Okay. How about this one? I know in years past, this one has been a little bit confusing when you see it. So this is on the review. And this is number 15. My pen will work. There we go. And they have the probability of 4 with C on top of it. Can someone tell me what that C represents? It's going to be our complement, okay? So we've talked about that a little bit here. So let's go over this here. So the complement is when you do 1 minus the probability of that. So when you're looking at this, we're talking about a standard deck of cards, right? So we're 52 cards, 4 of each one, 13 of each suit. I would write this as 1 minus the probability of choosing a 4. Well, what's the chance of pulling a 4? 4, sorry. Ugh.
4 over 52.
Perfect. So to find the answer to this guy here, you would just do 1 minus that. So another way of writing 1 is I could always write it as 52 over 52 to make it a little bit easier for us to see. And if I do 52 minus 4, I get 48 over 52, which is 12 over 13. I know the C sometimes confuses people, so I wanted to make sure we went over that.
Okay.
We got anything else, guys?
What's the difference between the formula that says the and the or?
Well, when you're talking about inclusive and exclusive, that's going to be using or, and that's when you're going to be adding, okay? Or subtracting the overlap if you have that.
Okay.
Independent and dependent is and that's when you're going to be multiplying. So or is add, and is multiply.
So even when it comes to like those little union symbol thingies?
Yeah, so you have to know the difference between those two. So like or would be the U, and then and would be the upside down and type thing. Yes.
Okay.
Did that help any, guys?
Yeah.
All right. There is also another meeting today at 3 o'clock, a Google Meet with Miss Fayed. Okay. And Coach Jones has a video of her going through the entire review, and that's on all the e-class pages, is also on her YouTube channel. And she also did a video going over the Zoom the other day, which was going over the activity and taking questions and stuff like that, okay?
Mm-hmm.
And like I said, we have extra videos that we have been working on today and uploading and stuff like that as well to try to help you out. Is there any last minute questions before we end the session? All right, guys. Well, I hope you have a wonderful day. Make sure you study for your quiz. If you need anything, let us know, okay?
Okay, have a good day.
You too. Have a good one, guys. Bye.